The expression for the period of the simple pendulum is given by t is equal to 2 by under 10 by g. Now, if we consider a situation in which the bob of the simple pendulum is displaced to certain position where angular displacement is g, and say this position P, position OP of the string with respect to position OA has a level difference of h. Then we can obtain certain different equations in these situations with the assumption that the h is the extreme position of that P position is the extreme position of the oscillatory system of the pendulum, bob of the pendulum. We can find out the value of h as L in the bracket 1 minus cos theta. The work done in moving the bob from the position Q to position P is given by W equal to mgh, where m is the mass of the bob of the pendulum and g is acceleration due to gravity at the given place. H is the height through which the bob is lifted. So this equation becomes m into g into h can be expressed in terms of L as 1 minus L into 1 minus cos theta. This work done is stored in the form of potential energy. So potential energy of the bob at this position P will be equal to m into g into L in the bracket 1 minus cos theta. Now suppose that the bob starts moving from position P where it is at momentary rest. So the kinetic energy at P will be 0. Now it starts to move toward the position Q. This potential energy starts to changes in its kinetic energy. And the velocity which is obtained by the particle when it is at lowest position, that is at mean position or equilibrium position, is given by V is equal to V at Q. This will be V max, which is equal to under root 2 GH, or is equal to under root 2 in the bracket G into L into 1 minus cos. This is the velocity achieved by the pendulum when it is at position Q. Similarly, kinetic energy, of course this is maximum kinetic energy, which will be equal to potential energy at position H, and it is equal to mg L 1 minus cos. This can also be found out by using half m into v square. Vq is root 2g in the bracket L, g into L in the bracket 1 minus cos. Brackets. So it becomes mgl in the bracket 1 minus cos. Now the tension in this. At point T, the tension in the string will be equal to mg cos theta. At lowest position, that is at point Q in the figure, this will be maximum tension and it will be equal to mg plus mv square by L. That is the centripetal force. mv square by L has to be taken into account. So T maximum equal to mg plus m by L into v square, that is 2gl in the bracket 1 minus cos theta. So equation becomes mg plus 2mg in the bracket 1 minus cos theta. If we rearrange this term, mg plus 2mg minus 2mg cos theta, we have the result for the maximum tension as 3mg minus 2mg. We will consider oscillation of the simple pendulum in different situations. That is, in a lift. Suppose that lift is stationary. That is V equal to G. The effective acceleration will be equal to acceleration due to gravity, and the period of the simple pendulum in this situation will be equal to 2 pi under L by G, where L is the length of the simple. Now suppose that the lift is moving with constant velocity, either in the upward direction or in the downward direction. Once again, G effective will be equal to G, because acceleration will be 0. Acceleration of the motion of the lift will be 0. So G effective will be equal to G, and period T is equal to 2 pi under root L by G. So the period of the simple pendulum is not affected whenever the simple pendulum is in stationary lift or it is moving with constant velocity, either in the upward direction or in the downward direction. Now, if we assume that the lift is accelerated upwards with acceleration in this situation, G effective will be equal to G plus T, and T dash will be equal to 2 pi divided 2 pi into square root of L divided by G effective, that is G plus. It is quite clear that T dash is less than T, as G plus A is greater than G, T dash will be smaller than T. So whenever the lift is accelerated, the period of oscillation decreases. If the lift is accelerated in downward direction, with acceleration A, then G effective becomes G minus, and T dash will be equal to 2 pi under root of L divided by G minus. As G minus A is smaller than G, the T dash will be greater than. So, the period of the simple pendulums will increase when the lift is accelerated downwards with acceleration. Now, there is a particular situation. If this downward acceleration of the lift is equal to acceleration due to gravity G, then the effective acceleration will be equal to G minus G, will be equal to G, and T dash will be equal to 2 pi under root L divided by G effective will be equal to 0. T dash will be equal to infinity, or frequency of oscillation M dash will be equal to 0. So, when the lift starts moving downward with acceleration equal to acceleration due to gravity at the given place, then the period of oscillation of the simple pendulum in such lift will be equal to infinite. That is, it will take infinite time to complete one oscillation, and the frequency of oscillation will be 0. In other words, the simple pendulum will not oscillate, or it will oscillate with a period of infinite time. This is the same situation which happens at the center of the earth. At the center of the earth, acceleration due to gravity A or acceleration due to gravity G will become 0. So once again, the period T dash will be infinite. The same thing happens in an orbiting satellite around the Earth. G effective becomes 0 and T dash will be infinite. So, the simple pendulum will oscillate with infinite time if it is in the lift, is accelerated downward with an acceleration equal to acceleration due to gravity. The same result is obtained in case of an orbiting satellite, simple pendulum in an orbiting satellite, or it happens at the center of the Earth. If we use a metal string to suspend the bob, then there will be effect of temperature. If we use a wire, metal wire, then the temperature change can cause change in length and the corresponding change will take place in the period. Now if T is the period in ordinary condition, or the length of the pendulum L, place in a place where acceleration due to gravity G, T is equal to 2 pi under root L by G. This is at room temperature. Now suppose that L0 is the length original. Now suppose that due to rise in temperature delta theta, this L0 length changes to L. Then the increased length L is given by L0 in the bracket 1 plus alpha into delta. The corresponding corresponding time period is taken as T, where T0 for the L0, then T divided by T0 will be equal to square root of L divided by L0. From this equation, we can write L by L0 as 1 plus alpha into delta. So, we have T by T0 equal to square root of 1 plus alpha into delta. 1 plus alpha into delta theta raised to 1 by. If delta theta is small, then we can write 1 plus 2, 1 by 2 alpha into delta, or 1 plus alpha into delta theta bracket raised to 1. So T divided by T0 becomes 1 plus 1 by 2 alpha into delta, or T minus T0 minus 1 is equal to 1 by 2 alpha into delta. T by T0 minus 1 can be expressed as T minus T0 by T0, or is equal to delta T by T is equal to 1 by 2 alpha. So this is the fractional change in the periodic time caused by the change in temperature. If temperature increases, the period will also increase. So this is the effect of the temperature on the period of the simple pendulum, in which the metallic string is used to suspend the ball. In case of charge bob of pendulum, in presence of electric, now suppose that the electric field is directed upward. This will cause a force in upward direction, in addition to force mg in the downward, and this force will be equal to q into e. The corresponding acceleration will be q into e by m, where m is the mass of the ball. So g effective becomes g minus q into e divided by. The period of the pendulum in this situation will be equal to t equal to 2 pi under root L divided by g minus q into e by. Now if we consider the electric field is in the downward direction, then the resultant downward force will be mg plus q into e. Mg its own weight and q into e due to the electric field in the downward direction. If E is the intensity, then force is Q into E, where Q is charge on the plus Q charge on the metal sphere. So G effective becomes G plus Q into E by M, and period becomes T equal to 2 pi 10 to square root of L divided by G plus Q into